Next, we are going to see how we can do Boolean indexing in series. This is identical to what we have done in NumPy, all right? Just to save a little bit of time in these videos, I just defined a dictionary called grades. It has students, let's say, names as keys and grades as their values, all right? One thing that I want to introduce to you is none with capital N. Ran, this student does not have any grade. So instead of I can write np.nan with lowercase n, or instead of that, I can write none. All right, they are going to be identical for our application. So let me run this. And now that I have a dictionary, let me turn it into a series. I'm going to say series underscore grades is equal to pd.series of series of what? Grades. Yeah. And let's look at series grades, and it is going to say, of course, James, Yifan, Nasser, Rand, Dan, and Milo. They are going to be our indices, and these values, including this none, they are going to be my actual data in this series. All right, you see that pandas turn that none to nan, saying this is not a number, so I cannot allocate any numerical value to this. And if you notice, another thing that this is a little bit is going to get into details, is that each of these numbers, they are integer, right? But numbers that I have here, 86, they turn to float, and this is float, and data type, it actually says float 64. This happened because of this NaN, right? Non-value. This non-value is float 64. It supports this data type, NaN, right? That's why pandas turn all of these numbers to float. Now that we see what we have as a series, let's look at its average. All right, let's look at you know what? Let's start with a Boolean indexing. I'm going to say series grades. Tell me which ones are bigger than or equal to. Let me define 90. Right, I want to get A students here. It is going to say James false, Yifan true, Nasser false, Ran false, and Ran by default, because it's missing value, it is going to be false. Dan is true, and Milo is false. All right, it provides very nice Boolean indices for this condition. Right, this is sometimes known as a mask. You just define a mask, but that is for another time. Now I'm going to say, you know what? I want values of series grades that this condition is true. Series grades, they are bigger than or equal to 90. I want to know I want to know those actual values. The A students that I have is Yifan with a grade of 98, and Dan with grade of, with grade of 93. Now, let me introduce you to something that at the beginning it is going to be a little bit strange, but this is one of the nice and very powerful properties of a Boolean indices, all right? Boolean indexing. Sorry for these mistakes. It's a little bit late. So what I have right now is I want to know which students they have performed better than average of the class. All right. Now, what is my condition? My condition is series grade is bigger than or equal to series grade dot mean. Right. That is my condition. Right. Yes, you can have series in both sides. And it is going to say James is that is true for James, that is true for Yifan, not for Nasser, not for Ran, not for Milo. Now I'm going to actually change it. Right, you can write it in just one line, it doesn't really matter. Series grade at what? Series grade, series grade bigger than or equal to series grade dot mean. Right, this is going to give me students names and their grades, but it is going to give me only those students that they perform better than average of the class. All right, with just one line you can get that. And it is going to say James is better than average of the grade class with grade of 86, Yifan with grade of 98, and Dan with grade of 93. This Boolean indexing is very, very powerful, and we are going to use it heavily moving forward.